Hello everyone. I'd like to continue talking about something that we talked a bit about in class last week, which is abstract data types. So an abstract data type is sort of like an API for our data structures class. So let me start with an API again. So an API is an application programming interface, and it's really, it's the bare bones description of some functionality, right? So this would be analogous to like a header file in C++ if you're following convention. So basically like, the parameters to a method as well as the return type or information. Basically everything that you need to know to use the method, but what we're leaving out crucially is the implementation details. So no implementation details about the functionality. So look, what I'm saying is, hey, I'm going to give you the car. It's got a gas pedal. It's got a steering wheel. You don't need to know how the engine works to drive that thing. Okay? And so an ADT is an API specialized to a data container of some type. All right? So let me give you an example, and I think I'll see more what you'll see more what I mean here. So let's think about this set ADT, which is one that we'll be looking at a lot in this first unit. So a set is a collection of objects in no particular order without repetition. Okay? So, mathematically we would write it as, 2, 7, 1, and then some other of my favorite numbers, 17, 7, 3. Okay. So these are in no particular order. They're denoted by these curly braces. That's both a mathematical notation and also a Python notation for sets. And so that's it. Okay, so it's this unordered collection of objects. So if I want to realize this in a data container, what I'll do is I'll create a set ADT, which has 3 methods we'll start with. So we want the ability to add some object to the set. So this is really a void method. We don't have explicit return types in Python, but this won't return anything. So in Python it's essentially going to return none. So we're going to have an add, whose purpose is to add our object to the collection, to the set, if it doesn't exist, or do nothing if it's already there. Okay, so nothing to change. If I were to add a 7 to this here, 7's already there, so nothing to do. I also want to have a contains method, and so this is actually going to return a Boolean. So return true if object is in the set, or false otherwise. All right, so I want contains. That's a part of my ADT. And for now, the last one I'll put in there is remove. So void remove object. So this will remove, let me just call it obj again, remove object from the set if it's there, or actually I want to throw an exception if it's not there. And I'll show you how to do that. Okay, so that's the ADT. And so these are the methods that I'm going to have in a class, actually. That's how I'm going to realize this in Python. Notice I didn't say how they were going to work, though. Okay, so basically it's just like the skeleton, the sort of thing you would put in a header file in C++. So, I'll make a class called set. Maybe I won't do anything special. I'll just put a pass here. Python requires there to be at least one line in every body of a method or if statement or anything. So I'll put pass there for now just to get the code to run. And then I will have these 3 methods. So add. Remember, every instance method has to have self as the first parameter. So again, I'll do a pass. I'll say def contains. And this is certainly not a proper implementation, but maybe I'll always return true. And then remove. And I'll just do a pass on that because it's supposed to be a void. Okay, so this is like my bare bones. This is the ADT. But under the hood, we're going to have to talk about the data structures, okay? So a data structure, on the other hand, is an underlying implementation that realizes an ADT, so that actually makes it work under the hood, all right? So in this example, let's start with an unordered list as the underlying data structure. So I'll rename this to list, or I should say unordered array as the underlying data. So I'll rename this to ArraySet here. All right. So what I'll do actually is I'll start off here with an empty array. So I'm going to use NumPy's array here because Python lists can actually grow, but a NumPy array is fixed in size. So it behaves more like a Java or C++ array. If we want to add or remove something from the array, we have to create an entirely new array and fill that in. So entirely new array of a different size. Okay. And that's because when we allocate arrays, we're actually taking a whole chunk of memory of a particular size from the heap. And if we want something of a different size, we have to take an entirely new chunk. Okay, so that's pretty standard. Okay, so let's start off by implementing the contains method because that one's probably the easiest. So my philosophy here is we're going to be innocent until proven guilty. So I'll say, whether it was found, I'll say not in the list. But what I'll do is I'll loop through and I'll say if the array at index I is equal to the object I'm looking for, then I'll say found equals true. And I'll return found. And actually, I can make this a little bit more efficient on average if I, instead of using a for loop, I use a while loop. And I'll say while I is less than the length of the array. Whoops, and don't forget the self dot here. Array is an instance variable, so I'm going to make sure I have self dot that array. So while I is less than the length and we haven't found what we're looking for, we'll do it like this. Okay, so if I found what I'm looking for, I can go ahead and do that. Otherwise, I have to keep walking through this thing. If I go to the end, I'm done, even if I haven't found it. Okay. So that's my contains method. When it comes to doing add, I actually have to make a new array with enough space. So what I'm going to do here is, okay, n is how many elements are in the array currently. I'm going to make a new array with n. Well, actually, before I do that, let me make sure that the element that I'm trying to add isn't already there, right? So I don't want to add duplicates of it. So here I'll be a little bit careful about that. And I'll say, I'll just move this below just to define them in the order that they're used. But so I'll say if not self.contains object. So if the object is not there, well, then what I'll do is make an array that's one bigger. So I'll say new array is equal to np.zeros n plus 1. So make an array of all zeros that has one extra element. Step 2 is copy everything over from the original array. So I'll say for I in range n. I'll say this new array at index I is equal to what was in the old array at index I. And then step 3 is I'll add this new thing, add this new object to the end. All right, so that's a simple thing. New array at index n. Okay, so it has n plus 1 elements, so the last index is n now. I'll put this at the end. All right, so I might as well just add this new thing to the end. This is an unordered list. All right, so then the last thing I need to do is overwrite the array that was there, my internal array, with this new one that I made. Okay, so I'm going to remember this is now a new array with a new object at the end of it before I continue. Okay, So now I'm going to start to implement the remove method. I'll have you finish. But yeah, we're going to start off a similar way. We're going to say, hey, I'm trying to remove something. Is it actually there before I do anything? In this case, though, if I look back at the ADT, I'm supposed to throw an exception if it's not there. Okay, so I'm saying if you're trying to remove something and it's not there, I'm going to crash the program because something's gone wrong. Okay. If you try to add something to a sentence already there, it's not a big deal. You don't need to do anything. But if I'm expecting to remove something and it's not there, I've got to say there's something wrong. So the way I do this is by raising an exception. And this is something that you'll do in homework 1. So if I say here, raise key error, that's the same one we'll use in homework 1. I'll say list does not contain, or I'll say cannot remove non-existent object, and then obj. So this is, I think I showed this once or twice in class, but this is a placeholder in a Python format string. And I'm just going to plug in whatever object it is that I'm trying to remove there. All right. So let me run this real quick. Actually, I've got to make sure I import this stuff because I'm using NumPy. So I'll run this code, and actually I have enough functionality now to add a few things. Now the way that this array is set up, I can only actually add numbers for now. I can't add strings or anything like that, but it's fine. It's just for demonstration. So we'll make it a set of numbers. So maybe I'll try to do something like I had here, and I'll set that up. So what I'll say is I will say, you know, my set is equal to array set, so I'll instantiate a new one. Good, that ran. Now I'll say, let's see, the numbers I want to add, my set dot add, or maybe I'll do this in a loop. I'll say for x in 271 1773. So this is a for loop that'll loop through all these. So I'll say my set dot add x, and we get an exception because I misspelled this variable. It's supposed to be lowercase f found. Okay, so that seems to have run. Now let's see if it actually finds certain things. I'll say print my set dot contains 2. That's true. Great. Print my set dot contains 7. That's true. Let's try print my set dot contains 100. False. Okay, good. Seems like it's working. I should probably write some more extensive unit tests. So one last thing I want to note before I set you loose, there's actually some syntactic sugar we can use in the Python data model here. So Python objects come with a bunch of little built-in methods, and you can override their behavior. So technically, there is actually a contains method already in a generic Python object. It's actually called underscore underscore contains underscore underscore. And this is a method that's expected to return true or false. It's up to you how you implement it, though, if you're going to override it. So I actually have all the functionality here already, but now I'm going to override a built-in method. And if I do that, I can use some syntactic sugar, that's what we call it. I can make this look very nice. So instead of saying my set.contains 2, I can say print 2 in my set. Let's just see if that runs. Okay, now I don't have the old method anymore, so let me go ahead and say 7 in my set, 100 in my set. Oh, okay, and I also then, I need to update it in my add and remove method. So I'll say if not object in self. That's actually how we would write that. So let me tell you what's actually going on behind the scenes here. This in is actually going to call the contains method. It's kind of cool. So what it really is saying behind the scenes is this. But see how much nicer that looks? If not object in self. It's almost English. Okay. Okay, so now this works and it's very clean. All right. So when we can, we're going to use these built-in methods just so that we are using generic Python abilities. All right. So, but let me have you finish the remove method now, and then we'll keep going with the ADT story.